Today we are going to be adding and subtracting rational expressions with unlike denominators. However, we do have one with a like denominator, so we'll get to practice one that we saw before. So the first step on these problems is always look at the fraction that you have and see if you can reduce it. If you can, it'll make the problem a whole lot easier. So for instance, here I have a 3 and a 6. See, that can reduce. I can reduce this by taking out a 3 from each of those terms. I can also take out an x here, which will take out one of the x's down below, leaving me with 1x. So what I've got is a 1 over 2x. That makes the problem easier. Over here, you see how this x here will cancel out this x, and then 2 goes into 4 2 times. So what I've got left over here is 1 over 2. So now we've got an easier fraction to deal with, and what we can end up doing is to come up with that common denominator is just multiply it by x over x. Now if you're really looking at this problem carefully, you'd see that we already had an x. So if I just knew that I needed to make a 2x, what did I need to take out to make that 4x a 2? I only really needed to take out a 2. However, I didn't see that right away, so I went ahead and took out everything that I had there, and I'll multiply across to come up with that common denominator. So I still have 1 over 2x, but now I have x over 2x. And now I can combine these terms as 1. So you see how the denominators are the same? I'll just add up the numerators. However, can't add 1 plus x, so you just leave it as two separate terms. I'll put the x first because that's conventionally how we do it, and my answer is x plus 1 over 2x. Now a common mistake is people want to cancel out the x's, but you can't do that because it's not really x on top, it's 1 more than x. So let's use that same technique we had done before. 4 over 3d, no canceling goes on here, but here we could reduce. See, the 2's can cancel out, and I could take out 1d from the bottom to leave me with 2d's. So I'm left with 1 over d to the second power. So let's rewrite what we've got. 4 over 3d minus 1 over d to the second. Now we have to look at the denominators and see what each of them needs. So let's take a look at the first one here. See, this one has a 3 and 1d. This one has 2d's, so in order to make them so they have the same, this one here on the left needs an extra d. So we'll multiply by d over d. Now we're left with 4d over 3d squared. Minus, now what does this one need? Well, this one already has the d squared. It's just missing the 3, so we'll multiply by 3 over 3, leaving me with 3 over 3d squared. So now I can combine these two fractions together because they have the same denominator. So my answer is 4d minus 3 over 3d squared. Again, you can't cancel out the d's here because it's not really 4d. It's not d up top. It's 3 less than 4d. So there's my answer. Next one here, same sort of thing. Take out common factors. Make the fraction easier to deal with. So this n will take out one of the n's down below, leaving me with 2 n's. So let's rewrite what we've got now. 2 over 5n to the second power. Plus, now, same sort of thing. Let's take out this 2 and this 4. So we changed the 4 to a 2. The 2 down below is gone. This n will take out one of the n's down below, but if you're careful, you look at it, before we do that, we want an n squared. So let's leave that in. Let's go ahead and undo that mark, and let's leave it as n squared. So let's rewrite what we've got now. 2n over n squared. See, I already have an n squared with both, so all I need to do is take this second fraction, the one on the right, and multiply it by 5. And then they'll have the same denominator. So now let's rewrite what we've got. 2 over 5n squared plus 10n over 5n squared. And so now I can combine these two fractions as one. 2 plus 10n makes 10n plus 2 all over 5n to the second power. There is my answer. Well, let's take a look at this next one here. So we've got a common factor Well, no common factors up on the top or bottom of the fraction. So what we're going to end up doing is just combining this as 1. See, the denominators are the same, so I can add these two fractions together. 4x squared plus 14x squared all over 9. And so I add that together, I get 18x squared over 9. Well, now we can reduce. So you see how the 9 goes into 18 two times. So I'm left with 2x squared. That was the answer. Doesn't have to go any further than that. Well, let's take a look at this next one here. Here the denominators look almost the same, but we can't combine them the way they are because they're not. See, this is 1 less than x, this is 1 more than x. So I can't just multiply by a negative because it would make the x negative. And I want to keep it positive. So I'm going to multiply this one by x plus 1 over x plus 1. On this side, I need to multiply by x minus 1 over x minus 1. So the part that most people mess up on is not doing the distributive property. You've got to distribute the number in the numerator by the expression that you're multiplying by. So 3 times x makes 3x. 3 times negative 1 makes negative 3. And this is all over an x minus 1 times by an x plus 1. And then on this side, we have a plus 2x plus 2 all over that x minus 1, x plus 1. And so from this point, we can combine some like terms. Let's go ahead and do that. See how the x's will combine. It's a plus sign, so we just have to look at the signs that are in front. So we're adding those two together. So 5x. Over here we have negative 3, positive 2 makes a negative 1 all over our two factors, x minus 1, x plus 1. Now you can leave the answer this way for me. Sometimes they end up multiplying the denominator, and if you did, you'd end up with an x squared minus 1. It's a difference of 2 squares. So you can have the answer either way. I'm fine with. Let's move on to the next one. Same sort of thing. But this time it's a negative sign. So first thing I'm going to do when I see that minus sign, I'm going to change it to plus a negative. Plus a negative. And that, there's only one term up top. If there were more than I'd have to change all the signs in the numerator. So now I'm going to come up with that common denominator. So again, same as the last one. You don't have they're not the same. They look the same, but they're just actually 2 numbers off. Now I need to multiply the left one by x minus 2 over x minus 2. The right I did x plus 2 over x plus 2. So I multiply across. Now I've got x minus 2. And since it's an addition problem, let's go ahead and just write it as one fraction now. Negative 1 times x makes a negative x. Negative 1 times 2 makes a negative 2. This is all over this x minus 2 and the x plus 2. So they're the same denominator, so I was just able to combine them as one. So I go ahead and collect some like terms here. I got this x here, a negative x here makes 0. They cancel out. Well, here I have a negative 2 and a negative 2. That makes negative 4 over this x minus 2 times by the x plus 2. Now, they could leave the answer this way, but if they didn't, they would go ahead and multiply those two binomials. So negative 4 over an x squared minus 4 is another way to write that answer. Well, taking a look at this next one, always look to cancel, but there's no canceling that we can do. So we just need to multiply by the other's denominators. This one needs a 3x over 3x. This one needs an x plus 2 over an x plus 2. So we go ahead and use that distributive property up top. So we've got an 8x plus 16. And then over here it's an addition problem, so let's just go ahead and multiply. We get a plus 18x. Down below we've got this 3x multiplied by an x plus 2. So we go ahead and collect some like terms. We've got the 8 and the 18 can combine as one. So when I do that, I end up with a 26x plus 16 all over this 3x plus x plus 2. And so, actually not plus there, so let's fix that. It should be a multiplication sign between the two. So from this point, what we want to do is we want to see if we can cancel anything. Now there's a common factor. We could take out a 2 from this term here, but if I do that, it doesn't get me too far. You see, I'm left with a 13x plus 8. and there's no 2 on the bottom. If this was a 2 instead of a 3, I'd be able to cancel something, but there's no canceling that can occur. So you could leave the answer the way it was initially, or you could go ahead and multiply out the denominator. And if you did that, you'd end up with a 3x squared plus 6x. So one of these two ways is good to leave the answer. Let's take a look at the last one here. This one needs to be a 2x over 2x, but before I do that, before I get excited and come up with that common denominator by multiplying by the others, I see something. See the 2 over 2? Well, that will reduce. Let's do that. Let's reduce this fraction. Let's try to make it easier on ourselves. So let's take this 2 out. Make it just a 1. So now it's just 1 over x plus 1 over x plus 4. And you see, this will be easier to deal with. Now, a lot of people are going to want to just multiply the left side by 4, but that will give you 4x, not x plus 4. So these denominators are not the same, so we need to multiply by the other's denominator. They have no common factors, so the right side needs an x, the left side needs an x plus 4 over an x plus 4. So you use that distributive property up top, you've got an x plus 4, and then here 1 times x makes just an x all over this x times by x plus 4. Collect some like terms here. We've got 2x plus 4 all over a x times by x plus 4. Well, you could take out a 2, but it doesn't do you any good because there's no 2 down below. So you could leave the answer this way, or we could go ahead and distribute that x over that sum in the denominator, and you'd end up with an x squared plus 4x. So either way, I would take as an answer, and those are the problems that you'll see on tonight's homework. So good luck.